Okay, all vocabulary aside, let's talk about some examples finally. And you may not necessarily need to know the vocabulary to solve these problems, but it's worth talking about because it can really help you in the long run in solving these things. So if we're looking at the probability of heads on a coin and a 1 on a standard six-sided die, if we think about and what it means in statistics, we're looking at multiplying here. So we can look at these events. They are independent, which makes our lives easier. And they are mutually exclusive. Meaning I have no overlap to worry about. So if we're looking at this, let's figure out the probability of the heads and the probability of the 1, which the probability of heads is 1 out of 6. The probability of 1, or no, forgive me there. The probability of the heads is 1 out of 2, or a half, or 0.5, or 50%, whatever you prefer. And the probability of rolling a 1 on the die is 1/6. So if the probability of both of them happening would mean that I'd have to take, so the probability of heads and 1 is going to be 1/2 times 1/6, which would be 1/12. So if I was to perform a roll and a flip 1/12 of the times, I could expect to get a heads and a 1. So let's look at another example here. We're looking at probability that I roll a 4 on a die or draw a 7 in a standard deck of cards. So both of these are mutually exclusive. They are independent, depending on, or it's not going to matter what I roll on the die. It's not going to affect the card, and vice versa. And likewise, they're mutually exclusive because on a die, I can't draw a 7 of clubs. And likewise, with drawing out of a deck of cards, I can't get the 6 on the die. There is no overlap here. So let's look at the probability of rolling a 4 on a die. Okay, that would also be 1 out of 6. Okay, and then we're going to have the probability of, let's say, drawing a 7. Well, there's 4 7s out of 52 cards total. So the probability of a 4 on a die or drawing a 7 is going to equal 1/6 plus 4 out of 52, which we can find common denominators or convert them to decimals and then add them that way. But that's how we would solve that problem. And since we're dealing with things that are mutually exclusive and independent of each other, one's not going to affect the other, we can just jump right to the addition because we're talking about OR. Okay, let's look at a slightly more complicated example. Let's say we're looking at drawing 2 kings from a deck here, and let's assume that we're not replacing the card as we do so. So really, this kind of a subtle thing here is the probability that I draw a king and a second king. Now, these events are mutually exclusive in that I can't draw 2 kings on the first go. But they are not independent because of whatever I draw on that first one is going to affect what happens on the second one. So let's look at the probability that I draw the first king. Well, there's 4 possible kings out of 52 total. So that one's pretty straightforward. We can keep that as is. Okay? And now let's look at the probability of the second king. So let's say I drew this first king. Well, now I only have 51 cards to choose from in total. And there's 1 fewer king. There's only 3 left. Say I pull out the king of spades. Well, that only leaves the king of diamonds, king of hearts, and king of clubs. So this turns into 3 out of 51. And since there is technically an and here, even though it wasn't written in the original thing, there's kind of it's implied that I want to have 1 king and then a second king. And sometimes that'll happen where you'll have to discern, is it an and, is it an or? And it may not be written directly in front of you. So these are the 2 events. And this is where the part where you may not necessarily need to know exactly what independence is. You just have to really think about how that first event will affect the second one. So I still follow the same rules. I'm going to multiply these two probabilities because I'm looking at n. So I'm going to have 4 out of 52. That's the probability of the first king times the probability of the second, which is going to be 3 out of 51. I multiply straight across. I'm not sure what that would be off the top of my head, but ultimately we would have 4 times 3 would be 12 divided by whatever 52 times 51 is. And that would be our probability of drawing 2 kings. Okay, last example. This is one where I'll highlight what it means to have 2 events that are not mutually exclusive. So in this case, we're looking at the probability of drawing a 7 or a spade. And you may find yourself thinking, well, there is one card that can be both. I could draw a 7 of spades. And we have to consider that possibility. So we're dealing with the or, so we're probably going to do some addition at some point. That's what the tip-off is there. But we have to be careful in how we do it. So let's look at the probability that I draw a 7. That's going to be 4 out of 52. That one's pretty straightforward. And then likewise, the probability that I draw a spade. Well, there's 13 spades out of the 52 total. But here's the thing. This includes the 7 of spades, and so does this one. So I'm double counting here. I wouldn't want to add them up because I'm looking at double counting that 7 of spades. It would have been counted twice, and there's not 2 7 of spades in a deck. So there's a couple ways you can think about it. Since we know a lot about a deck of cards, we can kind of reason it out. We can say, okay, there's 13 spades, and I'd also find success if I have the 7 of hearts, or the 7 of diamonds, or the 7 of clubs. And that would lead me to believe that there are 15 ways that I could pull this off. 15 out of the 52. So, if we're going through this, if we were to add 4 out of 52 plus the 13 out of 52, we'd be 1 above what we need, and that would make sense because we're double counting the 7 of spade 1 time. This would give me, oh, forgive me, it wouldn't be 15, it'd be 16 possibilities out of the 52. So we'd be looking at 17 here. However, if I subtract the overlap, the probability that it's a 7 of spades, there's only 1 7 of spades in the deck. So the probability that it's a 7 and a spade is 52, which is 16 out of 52. Now, for this example, you may not have had to do it that way because we know a lot about a deck of cards. However, there will be a lot of examples where you won't know as much about this, about the mechanics of it. So just be careful in how you do these. Think about each one individually. The and means you're typically going to multiply, or means you're going to add. And it can be a little tricky sometimes to figure out what you want to do, but once you figure out what to do, the math usually isn't too tough.